本场话题：科技前沿。
Our
下面
next
有请硅谷百年史作者、人工智能及认知科学专家 Piero Scaruffi 先生为我们发表演讲《智能非人工》。
Please welcome Piero Scaruffi, AI and cognitive scientist and author of A History of Silicon Valley, to give his speech, Intelligence is Not Artificial.
早上好。你好吗？ Chinese is so easy. Okay, too much. So, this is me 30 years ago, Silicon Valley, manager of AI center. I did not change much, right? So, what I'm going to talk about. Basically, I'm going to tell you something very simple, but it gets complicated in our days. A Chinese journalist asked me, "Are you afraid of artificial intelligence?" And I replied, "I am not afraid of artificial intelligence. I'm afraid that it will not come soon enough." And I'll explain what I mean by that. So first of all, we have 3 anniversaries to celebrate in 2016. The first computer in 1946. It's been 70 years of computers. I like this picture because it shows the original programmers. The programmers of the early computers were all women. Why women? That's an interesting story, but it's a different presentation. And from the very beginning, the media, this is an article from the 60s, the media were presenting the computer as the electronic brain. From the very beginning, they were predicting someday the computer will be as intelligent as us. Second anniversary, 1956 is when the first conference on artificial intelligence was held. So it's 60 years that we have artificial intelligence. Not surprising that artificial intelligence was born almost at the very beginning. Computers are invented, very few people can work with them, but we already have a field of artificial intelligence. And from the beginning, there were 2 schools of artificial intelligence. One school believed that we have to use mathematical logic to simulate how the mind works. And the most famous people in artificial intelligence actually belong to that school. Marvin Minsky, John McCarthy. The other school believed in simulating the structure of the brain. And that's neural networks. The problem with neural networks is that it was terribly difficult to build a neural network in those days. Computers were big, expensive, slow. So for a while, the logical approach, the knowledge-based approach, was winning. What happened in the next 50 years is Moore's law. That's the #1 factor to explain what has happened in the next 50 years, because a lot of the foundations were already there in the 50s. Moore's law, computers got faster and faster, smaller and smaller, cheaper and cheaper. And so neural networks became popular again, became feasible again. And deep learning is the grandchild of the neural networks, of the original neural networks. And that's the 3rd anniversary that we have to celebrate in 2016, because most people assume that 2006 is when deep learning was born. So 10 years of deep learning. And of course, as you know, progress in deep learning has been dramatic. Really, 2012 is when deep learning became the most popular technique in AI, and it's a long story what that means. But since 2012, every year, we have some sensational news. And so now we live in the age of the personal assistant. So I've been told that every presentation on artificial intelligence must have one slide of a Hollywood movie. And people usually pick really bad Hollywood movies. Terminator, I don't like Matrix, So I picked a good one, at least. So we live in the age of the personal assistant, or the automatic translation. Big companies are investing in AI. I think 2014 was the all-time record. And these are some of the companies around today. Valuation is significant. DeepMind is the one acquired by Google. And from the very beginning of deep learning, from the early days of deep learning, Go, Wei Qi, Go is the Western name. The game of Go has been a favorite of deep learning scientists. And since 2009, so now it's almost 7 years, computers have been beating masters of Go. So AlphaGo was not the first one. Since there's been so much progress in artificial intelligence, some people, who are actually a lot smarter than me, Bill Gates, Stephen Hawking, and Elon Musk, they have started worrying that artificial intelligence might become not just powerful, but dangerous. Machines might become dangerous. So as we speak, right now, Elon Musk and Peter Thiel are opening this non-profit organization in Silicon Valley called OpenAI, and they hired some of the best AI scientists in the Bay Area. Lots of progress also in robots. Of course, robots have been getting better at walking and at picking objects, which traditionally was the weak point of these objects. So now in Silicon Valley, a lot of people talk about the singularity. We are approaching the day when we will have a machine that is much more intelligent than us, in fact, so intelligent that we cannot even comprehend the machine. And this, of course, sounds a little intimidating. Oops. Now, the singularity, the whole idea of the singularity, in my opinion, rests on 4 assumptions. Assumption number 1, artificial intelligence is staging dramatic progress. Assumption number 2, progress in our days is accelerating exponentially in a way that has never been seen before in human civilization. Number 3, we'll have to deal with superhuman intelligence. And number 4, we are beginning to have machines that can do things that we cannot do. Now, this sounds reasonable, and most people agree with these assumptions, but I think they're all false to some extent. So let me tell you why I think these are false and why you can relax, and the singularity is not coming anytime soon to destroy our world. So first of all, a lot of the progress in AI, as I said, is really Moore's law. In terms of conceptual innovation, there has been a lot of progress. I'm not denying the progress in deep learning. It's very impressive mathematics. But without Moore's law, we would not have any of that. If we still had to work with the old, big, expensive computers, there would be no way of having AlphaGo. So Moore's law is still the number 1 reason that we are seeing these spectacular results in AI. And unfortunately, a few weeks ago, William Holt of Intel, not me, William Holt, announced that Moore's law is coming to an end. And my personal opinion is that Moore's law already stopped working a few years ago when Intel and AMD started packing more and more processors on a chip. So we'll see if these impressive results of AI will continue when Moore's law starts declining. Now, as I said, AlphaGo was an impressive achievement for many reasons, but again, it trained with 150,000 games. You need very fast and affordable computers to do that. And it used a technique called reinforcement learning, basically played against itself, thousands and thousands of games. That again requires an incredible amount of computational power that was just not available in the old days. So when we pay tribute to these great scientists, let's also remember that a lot of their achievement is due to faster processors. What else can AlphaGo do besides playing Go? Nothing. It does one thing. It does it better than those masters, but only one thing. Anybody in this audience can do a lot more than just play Go. And how does it do it? It learned from human experts. The human experts indirectly teach the machine what to do. My favorite is this one. I did a little calculation. 1,920 processors basically consume 440,000 watts. Your brain consumes 20 watts. So AlphaGo consumes 20,000 times more power to do one thing. Your brain does an infinite number of things. Who is more intelligent? So let's relax a little bit when we take this big news. Okay, assumption number 2 is that we live in an age of unique accelerating progress. Well, I like this age. Go back 100 years. In 20 years, in just 20 years, all these things were invented. The car, the airplane, the telephone, the radio, the record, cinema. Those things dramatically changed the world. The world was completely different after those 20 years. It all happened in 20 years. And at the same time, we built skyscrapers that changed the city. In those 20 years, most of the electrical appliances were invented. Most of the office machines was invented. So the home changed, the city changed, the office changed in just 20 years. Are you sure that today we live in an age of unique progress? Let me give you some data. The first robot that moves was built 47 years ago in Silicon Valley. Shaky the robot, 47 years. Now, cars. 47 years after the car had been invented, there were 25 million cars. 47 years after the plane first took off, 31 million passengers. 47 years after the first radio, more than 100 million radios, including every car built in the United States. 47 years after Shaky is today. How many of you have a robot walking around your house? Assumption number 3, oh my God, superhuman intelligence is coming. I argue that superhuman intelligence has always been around. We live with it. My favorite animal is perhaps the bat. The bat flies in the dark, very high speed, catches insects, and lands upside down on the ceiling. Can you do that? Can you smell as well as dogs do? Can you see in the dark like cats do? Superhuman intelligence is around us, and we live with it. Machines. Are we building machines that can do things that humans are not capable of doing? Yes, of course. But we've been doing that for a long time. There's no reason to panic. In fact, here I mentioned some, but my favorite is this one. I'm checking how many minutes I spoke. How many of you can tell me how many minutes have I been speaking? These machines can do it. These machines keeps time. It can do something that no human being can do, invented 1,000 years ago. So the 4 assumptions of the singularity movement are all very weak, actually. I am more concerned about human intelligence, because to make machines work, we tend to structure the environment with rules and regulations. You cannot have a self-driving car if you have not mapped the territory, if you have not marked the lanes, if you don't have traffic lights and signs. Rules and regulations. Rules and regulations don't make people smarter. They make people behave like machines. So I call it the Turing point. The Turing point is where the machine becomes more intelligent of humans. Well, that can be achieved in two ways. You know, you have machine intelligence, human intelligence. One way to reach the Turing point is that machines become a lot more intelligent. The second way to reach the Turing point is that machines become very little more intelligent, but humans become more stupid. So I hope we're not achieving the Turing point the wrong way. But that's not to deny that the AI is giving us a lot of applications. The most popular application of AI, unfortunately, is advertising, okay? Is advertising. They make you buy things that you don't really need. I'm a pessimist, and I think in the near future will remain the same. But some very useful, I said, I'm afraid AI is not coming soon enough. We need these applications. Service robots are coming, and the number one application to me will be elderly people and sick people. Societies like Japan are aging. They need somebody to take care of elderly people, and we don't have enough young people to do that, nor willing to do that. So we need that. We need robots to do dangerous jobs that today kill a lot of human beings. Deep learning will certainly stage a dramatic progress, especially now that we have reinforcement learning, that's become feasible. Even here, some of the applications are not very outstanding, but think of medical images. Philips alone has 100 million medical images that only experts can understand. We desperately need AI also for that. Progress in robots, there will be, because robots will start talking to each other. There's nothing wrong with that. They have to get smarter. Robots are extremely stupid today. They do just one thing and don't do it particularly well. They do it only in very structured environments. And robots, machines in general, need common sense. Common sense will not come from deep learning, in my opinion. We have to rediscover the logical approach. Otherwise, we'll probably not achieve machines that have common sense. They don't cook your cat when you tell the robot, cook food available in the kitchen. And there's some technicalities that probably are coming very soon and will make AI more powerful. There's some applications that are widely publicized. I always a little nervous when I see too much emphasis on the things that are available today. So beware of the publicity that things get. But I want to close with a positive message. As I said, I'm not afraid of artificial intelligence. I'm afraid it's not coming soon enough. And jobs. The society of robots will create jobs that we cannot imagine today. Who would have thought that the technology of computer automation would create millions of jobs in mobile computing? New technologies create jobs that you cannot imagine. And machines will create such a complex society that human intelligence will be even more valuable, not less valuable, more valuable. The future always surprises us. 谢谢。